Welcome to the Stormsurf video surf forecast for the week starting Sunday, September 20th. Looking at significant wave heights for the North Pacific Ocean, we see not a whole lot going on. The remnants of Typhoon Crovan proceeding northeast off of Japan, but not expected to do anything. A cutoff low pressure system well northwest of Hawaii, also expected not to do anything. You can almost see it, high pressure, totally dominating the North Pacific from the northern dateline region into the western Gulf. Not a whole lot going on there, and maybe some hint of some openness here in the Gulf of Alaska, but really a rather quiet pattern in control. Diving into the details, we'll take a look at jet stream level winds. These winds up about 30,000 feet help control the formation of storms, and when those storms do form, help direct their track. What we're looking for is a trough, that is, something in the jet stream like this diving to the south. And we see what would be called maybe a very weak trough trying to organize in the northern Gulf of Alaska, but off to the west we have a split jet stream flow, very much not supportive of gale development. This is kind of an interesting pattern because it has persisted lately, and one could say that due to, and we're talking El Nino already very early in the forecast, due to out in this region there's really no westerly winds going on, not trades either, but what one could almost say is an inactive MJO pattern here, and that's definitely affecting the jet to the north, giving it no energy and weak, where off in this region you have more of a westerly wind pattern driven by the developing El Nino base state, and that seems to be pulling the jet together a little bit. So one could, if we're stretching it, say that the jet stream pattern currently reflects what's going on with El Nino. Anyway, let's move forward. As we go back or move forward in time, we see much the same, this sort of split, muddled pattern here in the west, and a building trough by Tuesday in the northern Gulf of Alaska, working its way south into Wednesday. We're looking for stronger winds, and here we go, maybe 110 knot winds diving south. That would create a counterclockwise flow in the upper atmosphere, which also can manifest itself down in lower levels of the atmosphere, which is the hallmark of low pressure. And maybe, just maybe, we'll get some low pressure in this area. Actually, the models had looked much stronger a couple days ago, but in the past 24 hours, things have kind of backed off. Anyway, that trough gets pinched off by about Thursday, and then slowly starts working its way towards the U.S. West Coast. The bottom of the trough here, or the apex, is down around 35 north on Friday evening, and then it just pinches off and disappears. Now, here's where things get somewhat interesting. Notice the split jet stream flow starts disappearing here. We get more of a consolidated flow coming off of northern Japan with winds to 140 knots, and then sort of working their way into the Gulf. And we have a couple hours left in this before we hit the end of the pattern. And by Sunday night, early Monday, things are actually starting to look a little more promising, and not so much over the Pacific, but off here. Notice this is one big fat consolidated flow. This is more what we would expect to see if a major El Nino were in play, or it could just be attributable to a change in the seasons, but either way, it's moving in the right direction. So the thought is we have about a week of kind of nothingness going on, and then things might start getting a little bit more interesting. Also notice the jet here, Sunday night, actually we'll roll this down a little bit, almost a trough or some sort of maybe connection here with tropical air further south, working its way into California on Sunday. So that is a good sign also of some sort of a change in the season perhaps on its way. Next, we dive down to the surface. Surface level pressure, surface level winds, looking for gale development. Certainly we have what was Typhoon Crovan, again, east of Japan, still looking reasonably organized, but notice this big high pressure system here, and also the split jet stream flow on the previous chart, really giving Crovan nowhere to go and cut off from any fuel that would help develop it. So basically, it should just stall right here. And again, in the Gulf, we see what's that, a 1,004 millibar low, really nothing to shake a stick at, and just sort of this high pressure pattern off the California coast and north of Hawaii. Good for trades, good for east wind swell pushing into the islands, but that's about it, and low pressure here. Let's roll this into motion, see what happens. happens. And as expected, Crevon just starts fading out. A cutoff low tries to develop here south of this 1036 millibar high. That's a strong, impervious, impenetrable high. Roll this out a little bit more. This upper level trough probably just starts shearing Crevon, but also notice another broad tropical system is forecast off the Philippines by Tuesday night. Roll this out. Low pressure starts developing by Wednesday in the Gulf of Alaska. And again, these systems continue percolating over in the far west Pacific. We're looking for real fetch here associated with this Gulf low. Winds were supposed to be up to 35 knots as of, a day or so ago, but per the model now by Thursday, nothing really happens. It just kind of peters out. This new tropical system off of Japan is forecast to develop, looking very solid, covering a good size area, while high pressure continues south of the Gulf, off the U.S. West Coast, 25-knot winds, generating wind swell probably for California. And this is out a week from now. And again, continued wind swell into the Hawaiian Islands. And we continue to watch the tropical system develop high pressure. So basically, and we're at 180 hours, there's no real high pressure blocking this system's path. So charts looking somewhat promising at the moment. Let's take a look and see what effect these winds will have on the ocean surface. So here we go. Significant wave heights for the North Pacific Ocean. We see a rather placid pattern other than Crevon, and even that is not very big, very small footprint. It dies out as we get into Monday and Tuesday. The Gulf low, not really doing anything, not enough wind to get a strong footprint. The new system starts developing, and so where are we? We're in Wednesday night, Thursday. Again, nothing going on in the Gulf. This is the only system, and that's kind of a Hail Mary this early date. We watch it develop off of Japan and quickly move to the northeast. So we're pretty much, the interesting part here is all tropical systems now are going to the northeast. That would be classic El Nino symptoms right there. But there's no upper level jet stream support to help them go extra tropical. What we want to see is one of these systems make it to the date line, hit the jet stream, go extra tropical, blow up, and create long period swell pushing in into Hawaii and the U.S. West Coast. That would be the classic El Nino sign. The model sort of hints at that, but at 180 hours out, it is completely unbelievable at this early stage of the game. Still, something to tease us. In the meantime, there isn't a whole lot going on in the North Pacific. Let's do a quick check on the southern hemi. And here we are, significant wave heights for the southern hemisphere, South Pacific Ocean. We'll just roll this out because there is not a whole lot going on. A gale trying to generate seas under New Zealand on Tuesday. Quickly fades out. The jet stream pushing into Antarctic ice. Notice how Antarctic ice is well to the north now, up about 62, 63, almost the whole way across the entire South Pacific Ocean, cutting off a lot of room that otherwise would help support the formation of storms. We see some activity here on Friday night, a tiny patch of 32-foot seas, all going straight west to east. No swell expected, even if it does form. A better patch here, 35-foot seas on Saturday night, if one can believe that. Now, if that were to form, sure, there'd be some swell for Tahiti, Hawaii, U.S. West Coast, but we're talking minimal size, and it doesn't even last that long per the models. So for now, the southern hemi is basically asleep. We're looking at the northern hemisphere, just waiting for it to wake up, and basically, for that to happen, the jet stream has to wake up. We anticipate that shortly. It's all dependent on El Nino, and as soon as El Nino starts really digging in, and also waiting for fall to happen, the start of the fall transition, and that is anybody's guess when that will happen in earnest. Let's go move on. Our big interest, El Nino for 2015, a significant, strong El Nino is in development. So as we've done in the past, and we will continue to do, first we'll examine westerly winds in the West Pacific, because westerly winds or westerly anomalies help generate Kelvin waves. That is, they take warm water from the West Pacific, move it to the east, but not at the surface. It falls to depth, travels under the equator, just a couple of degrees either side of the equator, works its way to the east in a pocket called a Kelvin wave. That is a pocket of abnormally warm water that makes it almost to the Galapagos, if not into Ecuador, and then reaches the surface, gurgles on the surface, erupts effectively, warming warm waters in the Galapagos region, which then get caught by trades and start moving their way off to the east. And when they make it between 170 west and 120 in this area, that's called the Nino 3.4 region. Nino 1.2 is over here by the Galapagos. Nino 2, same area. Nino 3, a little further west. And Nino 3.4 is in between the Nino 3 region and the Nino 4 region. No surprise there. And that is where, if you get warm enough temperatures, it actually starts impacting the jet stream in the North Pacific in fall and winter months, enhancing it, and then helps generate storms, typically in the Gulf of Alaska or the Western Gulf. And that's why we're so interested in, one, monitoring the jet stream in the North Pacific, and two, monitoring all the facets of El Nino. So there's the quick overview. Let's get into the details. This first chart here looks at actual wind directions, wind speeds, not based on models, but on hard buoys down on the ocean surface. We clearly see westerly winds in the moderate strength west of the date line. This is what we call the Kelvin wave generation area, from about 135 to about 170 right in here. You get west winds, and they don't actually have to be surface west winds. They can be anomalies. Normally, you have trades in this region blowing east to west. When the trades relax, that allows warm water that's been normally pushed over here by trades coming the whole way across the Pacific. Notice upwelling cooler waters over here, warmer waters on this side of the Pacific. When the trades reverse or relax, this warm water starts working its way back to the east, and then you get a Kelvin wave. So that's what we're monitoring. Clearly, we have west winds. Here is anomalies. Clearly, we have just about strong anomalies, and this is not like been happening just the past day or two. It's been like a machine now for months. Not particularly strong. There was a huge westerly wind burst in the late June, July time frame. It backed off a little bit, but then it's just been continuous westerly anomalies in this region, piles of warm water moving off to the east. We're ignoring the water temperatures right now. We're just looking at the winds. Here's another way to look at it. These are anomalies, wind anomalies up at the 850 millibar level, up about 4,000, 4,500 feet, but that's a good proxy for what's going down at the surface. And these are differences from normal for this time of year and just day by day. You can see, and it's right here on the right here on the equator. The date line's right here, so it's this region right in here we're interested in. West winds, building west winds. West winds, or west anomalies. Building west anomalies. As of the 18th, strong building west anomalies. And then here we are today, 18C Sunday. This is the Kelvin wave generation area proper. West winds right here. 20 knots in this one little pocket. This per the GFS model, but a pretty decent sized pocket here of, what is that? 14. So let's say 14 to 20 knot winds right there. A broad area of west winds in the 18 plus knot range here, but they're north. So most folks say 5 degrees north is about the area, or 5 degrees south. And there's definitely westerly winds in the northern part of that, but all the real north winds are up here at 9 north. The point is, if the west winds are up here, you probably will not get a Kelvin wave. It is just this small band a couple degrees either side of the equator where the Coriolis effect kind of has not as, it doesn't direct eastward moving water off to the poles. It can proceed right, basically there's an open corridor right here. So it's just these winds here we're interested in. So things aren't looking too bad. We've seen this chart in the past. Again, this goes back in time to August 21st. The date line is, we'll take a look right down the middle of here. So the Kelvin wave generation area starts off about here and goes to about here. The reds and the, here we go, the reds. So the Kelvin wave generation is here to about here. The reds and the yellow, of course, are westerly anomalies. These are easterly anomalies. This is the typical El Nino pattern. You get easterly anomalies effectively north of Australia. You get westerly anomalies set up just west of the date line. And like I said, back in August into September. It's just been a machine. Little bursts of actual westerly winds, but mainly anomalies. Here we are right now. We're just setting up, and this is that little pocket we saw in the previous chart of like 20-knot west winds. A little bit of a westerly wind burst, not one that's big, that's going to move a lot of warm water. It is just this consistent pattern of months of westerly anomalies pushing warm water to the east. And the forecast for the next week, that's what this is here, basically suggests that pattern is to continue. And yet, here is another chart, but it plays the game the other way around. The past is down here in May. Here's our big westerly wind burst that we talked about that was in the end of June, early July time frame. But look, again, the oranges and yellows, westerly winds just continuing up. Here's the date line. We'll just drop this down here just a little bit so you can see it right there. There's the date line. Goes right up through the middle here. And so the forecast starts September 20th. More westerly winds forecast with a little bit of a westerly wind burst into the November time frame. And then per this model, things back off a little bit and the westerly winds start moving off to the east, which is typical of El Nino, mature phase of El Nino into the December time frame. Let's overlay, and here's the MJO. The big westerly winds in the June time frame were attributable to the active phase of the MJO. We're currently in this thing that one could call an inactive phase right here. We don't really believe that that's the case. The point being that there's another little pulse of the active phase. This is very weak, starting the end of September, and another little pulse sometime in November. I don't know if we believe any of that, honestly. Equatorial, not Kelvin waves, Rossby waves. That's what we want to see. The interaction of Rossby waves, which move from east to west, should theoretically help enhance the wind flow a little bit, these westerly anomalies. But in reality, neither of those really has much of an effect. It is the El Nino base state. I mean, so the number of you call them isobars, whatever you want to call them here, lines of contours, suggest that the peak of El Nino will be sometime in the late November time frame, at least atmospherically. Okay, but El Nino, the atmosphere is only part of the equation. It's the warm water movement that we're almost more interested in. So the short of it is, we're in for a good long haul of more westerly anomalies. So what does all that mean? What's the effect? But right before we do that, let's talk also about the MJO. We saw in the previous chart there was some hints of some weak MJO activity forecast. These charts from two different models, the ECMF and the GFS or Ensemble GFS model, but both suggest basically no MJO activity for the next 2 weeks. That is, when the projection is in the center here, basically a very weak pattern forecast. And also two other models here. The statistical model shows basically no MJO signal at all. The dynamic model basically shows the same thing. No pattern at all. Nothing coherent, nothing believable. This is not unusual. This is exactly what you want to see when you have a mature, strong El Nino in play. It pretty much shuts the MJO off. It shuts everything off, and it lives on a life of its own. So all these charts, though they look barren and vacant, are basically doing is saying El Nino is in control. So let's go take a look at the effect of those westerly winds on what's going on under the ocean surface. West Pacific here, East Pacific here, depth here, water temperatures, clearly a big bulge of warm water, and you almost can see it trying to surge off to the east. You can see the isotherm lines here of that warm water trying to work its way off here. Notice that some of these are the anchors off the buoys strung here, and a bunch of the sensors are down, so there's a lot not known in this area. These are estimations of what's going on, but it is the anomalies, differences in temperature for normal for this time of year. Clearly, we see a very large Kelvin wave. This from that westerly wind burst that we talked about the end of June into July. Temperatures 7 degrees above normal. And again, sensors are out here, so we miss the whole right-hand side of the picture. But we have a massive pool of warm water. It's actually not a single Kelvin wave. It is a reservoir of warm water because there is still westerly winds blowing up here, pushing warm water. You can almost see it in this image, pushing warm water to depth and just backfilling into this building pocket of warm water. This image actually depicts it better. Here is our warm reservoir. This goes to right about the coast of Ecuador. There used to be a little cold pocket right here that was preventing this warm water from reaching the ocean surface, and you can see it. And this image is much clearer. West winds here, I guess you could call it upwelling, not really upwelling, but westerly winds here, pushing warm water to depth. That warm water builds in this pocket, travels off to the east, and is just poised. You can actually see, there we go, some eruption, and let's pull a data point right here, right around 110 west, the whole way into about 95 west, and another finger here, working its way. The Galapagos are right in about here, and another finger of warm water trying to make its way subsurface into the Ecuadorian coast. All this warm water is going to come to the surface at some point and create a major warm pool, which should be the driving stake in the coffin of El Nino in a good way, not to its death, but to its peak. Another way to observe the Kelvin wave, sea level height anomalies. Strip out all the waves, strip out the tides, strip out chop, strip out all of it, and these are the deviations from normal in centimeters for normal. And what this suggests is there's this big bulge of higher than normal sea level in this area by 20 centimeters now, which is significantly high. What that suggests is massive amounts of warm water at depth, and the warm water is displacing surface water up a little. So basically, this is a way to look sort of down on the Kelvin wave and see manifestation of it in the ocean surface. And we've used this chart before. We like it a lot because it, again, has time going down the scale. West Pacific here, East Pacific here, and it's upper ocean, upper 300 meters ocean heat anomalies, differences in from normal. And effectively, you can see right here was one Kelvin wave that was last year in 2014 in the fall time frame, another from the October to almost December time frame, upwelling phase of the Kelvin wave cycles. This is normal. Cool water for a little pocket. And then here we got into this year, 2015, February, Kelvin wave. Very warm, starts erupting in May. Another Kelvin wave in the June time frame. Then the massive westerly wind burst that occurred late June, early July started generating a Kelvin wave. And look at this. This is just a very, very large area of very warm water working its way off to the east. Here we are, current time. The important part in this chart to notice is, notice how warm water receded from the Galapagos for a little bit. Now notice that it is filling back in. We believe this was, just like here you have the upwelling phase of the Kelvin wave cycle, we believe this was a little mini upwelling phase. With all this warm water pushing east, it's not surprised there was a little backdraft, a little pause, but the mother lode is getting ready to do its thing. So we've done all this talking about westerly winds, Kelvin waves going underneath the equator, erupting along the Galapagos, but here's what is the result of when a Kelvin wave, or in this case, 2 Kelvin waves so far this year, erupt. You get warm water. These are differences in normal for the time of year. Warm water builds up here, gets caught by the trade, starts working its way off to the west. And then they measure the Nino 3.4 region from here, just draw a little box, to about here to here. You have piles of warm water here. It gets caught, working its way off to the west, and it starts warming this region. That affects the jet stream. The jet stream affects the storm track, amplifies it, and then you have your big storms, more rain for California, larger surf for Hawaii and the northwest U.S. in the winter. Anyway, very prominent El Nino signal. If you look at all these charts for every 5 days since 1997, you will not find a signature this strong. The only thing that beats this is the El Nino of 1997. It stomps on this one because it was a much stronger signal at this time of year. But the interesting part is, most of it was eastward displaced. Most of the warmth was back in here. This year's El Nino has a substantial amount of warm water out here towards the dateline. The implications is, because it's in the dateline region And in the Nino 3.4 region, the impact on the jet stream should be the same. We'll see what really comes of that. Anyway, let's dive into the details real quick. We like this chart better. High res, 5 kilometer, and what you can clearly see here, and this is in degree increments, you can of course see the warm water signature. You can also see piles of warm water elsewhere. This is the so-called blob, warm water building up off the U.S. West Coast. Not necessarily attributable to El Nino per se, but we think that's more associated with the change of the Pacific decadal oscillation from a sort of a down phase to a phase that more actively supports El Nino development. But anyway, the point being, look at the very warm waters here, 4 to 5 degrees above normal. And remember when we looked in the subsurface chart and we saw the Kelvin waves starting to breach or affect the surface between about 110 and 95? Well, this image pretty much also suggests that that warm water, 4 to 5 degree anomalies, and this has only been showing up really good about the past week or two, though it's been in bits and pieces for almost a month now. But still, a very warm situation developing here. Notice not so much warmer water tucked up along Ecuador. We're a bit concerned with that. We think that is attributable to the upwelling phase of the Kelvin wave cycle. But even if it isn't, as long as you get warm water here and it works its way off to the west, who cares what goes on in this region? It's not really that important. And just a real quick look at differences just in the past 7 days. Notice warming is starting to occur here along the Galapagos. One thing we noticed here, there was cooler water. The trend is for the water warming north of Australia, which is a little bit of a puzzler here, but cooling off of Australia, warming here along Madagascar. The Indian Ocean dipole pattern appears to be taking better route or taking better hold here. We're not so worried about this at the particular moment. We're going to zoom in real quick, and we're going back to September 14th. Notice the warm water pattern not so prominent here. Here's the Galapagos, here's Ecuador. Not so much going on. This was during the upwelling phase. Now here's the most recent image. Very impressive. All has filled in. This is looking again back to the way it was, at least a month ago. We had a bit of a crash of water temperatures here when the upwelling phase happened. But now it looks like the downwelling phase is back in control. Very warm anomalies off Ecuador between there and the Galapagos. Just the last little pocket of cool anomalies right in this region. So this is a significant improvement in the past few days. And then off to the west of there, continuous, there was a pocket right here of cooler anomalies. That has been wiped out as of the most recent image, looking the strongest it's looked so far this year. And of most importance is these really warm anomalies, 4 degrees or greater in this region, basically stretching from the Galapagos almost to, about 113 west and growing in coverage. So again, this is what we believe is the signal of the third Kelvin wave of the year and the big one starting to erupt, a very good sign. Here is the temperature trend for the Nino 1.2 region between the Galapagos and Ecuador. We saw very good solid temperatures, 3 degree anomalies back in the June-July time frame. Then things crashed pretty much in August. This was the peak of the upwelling Kelvin wave phase, and we would expect to see these temperatures actually start coming up. They're at 1.6 degrees above normal, which we find kind of low. We would expect to see them stepping up significantly based on the chart that we just saw. So this is a little bit of a head scratcher, but we expect the trend to be dramatically up in the next few days. And again, another head scratcher. This is the Nino 3.4 index. Based on all the imagery we see, temperatures are warming. The peak warming here was, about 2.2 degrees back August 23rd. I mean, we're not far off from that. We're at 1.8. We would expect to see these numbers heading up also in the next few days, especially as that big pool of 4-degree anomalies starts working its way off to the west. We expect that pool to grow much more. So for now, but 1.8-degree anomalies, that is a strong El Nino in anyone's book already, and we haven't even started getting our way or into the meat of the third Kelvin wave. So we would expect temperatures up in the 2+ degree range. And one quick look, Galapagos Virtual Station. Here's dates down here. Here is temperature anomalies. We had a nice little spike building here a couple days ago, 5.1, 5.3 degrees. Again, we saw on the previous chart just a little bit of back off in cool temperatures, just approaching the Galapagos. They'll bleed through in the next couple of days, and then we expect to see anomalies back up into the almost 5-degree range, and it should be pretty much that moving forward. So we'll see. And so finally, we have warm water on the equator in the west, or in the East Pacific. We want to see it impact the atmosphere. There are ways to measure that. The first is the Southern Oscillation Index, differences in pressure between Darwin, Australia, and Tahiti. Negative numbers represent the active phase of the MJO, or perhaps, if they persist long enough, the development of El Nino. Clearly, we are on a good run of negative numbers. We've had a little hiccup the past 2 days, but things are going pretty negative. If you look at the charts, we expect them to start dropping more in the days ahead. The 30-day running average tells the story. Numbers consistently in the minus 15 range. Actually, the daily value, minus 13.0. The 30-day running average today, minus 14.51. The 90-day running average hit its peak right here. It was at September 16th, minus 18.56. When we've been saying when you hit minus 18, then you're in the strong El Nino category. Then you start getting excited. So we did that for a couple of days, but now we've lost a little ground. But we expect the atmosphere to also turn and see these numbers start heading negative, and again the 90-day average should drop as well. Next up, the ESPI index. So it does like the Southern Oscillation Index, but it doesn't measure surface pressure. It measures differences in precipitation north of Darwin versus differences in precipitation, and we'll say north of Tahiti, but it's a much larger area than that, and then they create an index. Clearly, during El Nino, you see typically drier conditions north of Australia, wetter conditions north of Tahiti. The current index is at 1.98. That is a very solid number indeed. Putting that in historical context, the big 80 El Nino of 83, Super El Nino, was peaked at about 2.2. We've already seen numbers that high this year so far. And then the other Super El Nino of 97, 98 was up to about 2.8. We are currently at about 2. So we are, and if you go across the 2 line, I don't see any El Nino that's a 2. You go across the 2 line here, I don't see any El Nino other than maybe the 92 El Nino. So we're in, since 1979, we're one of 3 that were that strong. Very impressive indeed. And we did this last week, but we'll do it again because it is so impressive. The multivariable ENSO index, it measures not just pressure, not just precipitation, but a whole host of 5 or 6 different variables, and then creates a number from it. And using this chart, you can stack. They only update it once a month, though, so we're sort of showing the same data over and over. But just to put this year's El Nino in context, the red one here is the 97-98 El Nino. The green one here is the 82-83 El Nino. Only 2 El Ninos have ever hit 3 standard deviations. These are super El Ninos. We are on track so far. Notice we're right smack in between the 82-83 and the 97 El Nino. So we'll see whether we actually get up to the 3 standard deviation point at some point in the next couple of months. But we're tracking well towards that. And finally, projections for sea surface temperatures in the Nino 3.4 region. Per this, the conservative model, the CFS version 2, PDF corrected. Temperatures right now, 1.8. This version says that's all they're going to get is 1.8. We find that pretty much laughable, seeing as what's going on in the, with the third Kelvin wave getting ready to erupt over in the Nino 1.2 region. We would fully expect temperatures to be up at least in the 2.2 range. This other version, un-PDF corrected, suggests 2.4 degree. That's probably closer to reality. That would be very warm indeed and would qualify as at least a very strong El Nino. And here we go. That would happen in the, let's say, the November-ish time frame, mid-November probably. And that seems probably about right on track, maybe even a little bit later than that. So the whole point being a significant El Nino is in development. So just to put a bow on things, right now, North Pacific not doing a whole lot. Jet stream theoretically supposed to come online a week out. Theoretically, a strong tropical system recurving northeast off Japan and supposed to tap that jet stream energy. We'll believe it when we see it. Sure looks like a nice tease though. In the meantime, El Nino continuing to develop, very strong already, in the strong category. We're looking, just for the record book's sake, to have it reach Super El Nino status. If nothing else, just because we like to see strong weather events and because we're weather junkies. Anyway, so things are looking rather good, though. Everything is on track. Major Kelvin wave erupting off the Galapagos and finally starting to work its way into the Nino 1.2 region between the Galapagos and Ecuador. And again, that is all just icing on the cake. If it doesn't fill in there, we don't really care. As long as it erupts and it advects over into the Nino 3.4 region, that's all we really care about. That gets us what we need. So for right now, historically speaking, if there were ever a winter to have significant large surf, this would be it, other than the 97 El Nino. So continue your preparations, do whatever you're doing, secure your property, get your board, your quiver all set up, do your training, and prepare yourself, because we expect that once the floodgates open, they might do one little swell, a little bit bigger swell after that, and then once the train gets rolling down the track, it's just going to keep hitting us. So, and we expect that could happen at any moment. So that's it for this week. We'll do it again next week, same time, same channel. See you then. Thanks for watching. Bye.